Okay, so I need to create a function. Oh, sorry, this is 2.2, number 27. So I need to create a function with x is -2 and x is bigger than, oops, less than -4. This stuff is not allowed. Okay, so I need to somehow construct a function that has this stuff not in the domain. Okay, so what do you start with?
I started with figuring out what makes things smaller than -4 not work.
Okay, so say we want to make something smaller than -4 not work, right? How am I going to do that? Good, I think a square root's probably a good idea. You guys see that? So I'm going to think about this. I'm going to have like f1. This is going to be try number 1 of x, right? Okay, so I'm going to do square root of x. Okay, I'm trying to tackle this piece first, right? X is smaller than -4, needs to be disallowed. What's this thing disallow right off the bat?
All negative numbers.
Anything negative. So right now I'm disallowing x is smaller than 0. Crap.
-4.
Take 2. -4 maybe. Square root of x -4.
Still negative numbers because
Let's see.
the negative number minus a negative number is still just a smaller negative number.
Yeah, so when does this thing start working?
When
Plus
x
or
is
outside
underneath
square root.
Maybe what if we think about this in terms of shifting? Maybe that would be easier. So here's the regular square root function, right? When I subtract 4 from the x's, what is that?
It's just shifting right. It's right. So right.
That's a before the rule subtract, which is a right shift. You guys see that? So that one turned into this.
Does that still apply if it's under the square root?
Yeah, it applies specifically because it's under the square root.
Okay.
There is the rule.
Oh, yeah.
If I did the subtract 4 outside, I'd move it up or down,
That's
right?
right. Okay.
So this -4 is a right shift, which means this is happening at 4 now. So this thing's disallowing x is smaller than 4. Crap, I went the wrong direction. So what's your take 3?
X plus.
Okay, you're going to do square root of x plus 4. Okay, I think that's probably good. So right now I'm disallowing x is bigger than -4, or smaller. Right, the graph of this thing looks like that. You guys cool with this? Okay, does -4 work in here?
Yes.
Yeah, square root of 0, 0. Good, cool. All right, so I've taken care of this bit. Check. Now I need to figure out some way to cut x's -2 out of that thing. So what do you want to do? Like, what's the easiest thing that comes to mind?
To divide it by 0.
Yeah, this?
Basically.
Totally. That's a great idea. Let's do that. You guys know how to punch a hole in a function?
You said x can't be equal -2.
Okay, that's lazy.
Divide by 0
Divide.
that place.
Yeah, I want to divide by 0 at that place. So f3.5. This is not going to be exactly that. Okay. So f3.5 of x is going to be, take the old f of x, right? And just freaking divide this thing by, what do I want to divide by? I want to divide by 0 when x is -2.
X
So
plus 2.
x plus 2 is an easy way to achieve that goal. You guys cool with that? Okay, this thing wasn't that thing.
Yeah.
what did I do here? I introduced a whole asymptote. You guys see that? Okay, so that's gonna do something funky, but whatever it's gonna do is gonna have an asymptote here, right? And let's see, maybe something like this, roughly. This is a really rough picture. Oh, and that's gonna go to 0 anyway, so it's gonna do something like that. I don't know.
Let me see.
Right, I just threw an asymptote in it too, and then I tried to figure out which way it would go, right? So things smaller than -2 are gonna make this negative, right? And so I'm gonna have something running off to negative infinity. Things a little bigger than -2 are gonna make this positive, and so they'll run off to positive infinity. And then I'm not really sure what the hell goes on in here, but I do know that as that gets bigger, right? As that gets bigger, it'll dominate, and I said it was going to go to 0, but I lied. It's going to go that way.
Wait, so how does x plus 2 equal?
I don't know what the hell this goes. Damn. That's going to get bigger, but dividing is going to get... Oh, it's under the square root. That's going to go to 0. Like I said the first time. It doesn't particularly matter. This does achieve the goal they asked me for. But how the heck do I just punch a hole in it? Because that would be better, right? Because I know what that picture looks like.
Well, I'm still wondering how x plus 2 would make you divide by 0.
X plus 2 makes me divide by 0 when I plug x's -2 into it. Right, so I just wanted to make divide by 0 at that one spot. Okay, so I'm going to call this a success. But what would a better success be? What's that one? I'm going to call this F4. This is awesome.
What other way can it not be part of the domain besides square root and other things like that?
I'm going to leave this square root part alone. I'm just going to modify one little thing here. So I'm going to leave this square root in here. So I've got square root of x plus 4. I'm going to leave your divide by 0 in here too. But if I want it to be the exact same thing everywhere except where I divide by 0, I'm going to put one of those on top too.
So it's a 1-to-1 thing.
Yeah, you guys see that? So x plus 2 divided by x plus 2 is 1 most of the time. Right? When is x plus 2 over x plus 2 not 1?
0.
Yeah, when it's 0 over 0, which is undefined, right? So this is how you go punch a hole in a function. You guys see that? This is also how you unpunch a hole in a function. You guys see the hole punch was putting this thing in there? What's the hole filler?
Cancel that.
Yeah, grouping this and saying that's 1. It's not actually 1, right? But you can fill in holes that way. That's the trick with basically all of derivatives. So every time you come to a derivative, and every time you come to the end of the limit definition of the derivative in calculus class, you're going to end up with this something over something that's undefined at just one spot. Group it, slash it, get it out of there, and then life is easier. Cool? That's that h over h cancel you kept doing.
I just have one general question.
Sure.
I just don't remember because we were talking about the shifts and everything. When for asymptotes finding, is it when the denominator equals 0, it's a vertical asymptote, and then when the numerator equals 0, it's a horizontal asymptote?
So let's not worry about the horizontals.
Okay.
Horizontals are a limit question, and they're a little bit trickier.
Okay.
We'll talk about horizontals more as we go, but for right now, I don't want to deal with it. This one especially is freaking creepy.
This
Cool.
class is kind of in a horrible spot, isn't it? It's like right in between wanting to know everything and like not knowing enough to know everything.
Yeah, it's actually in a really cool spot because we can play with a lot of things without having to do the hard details. Right, so the answer to this one was either one of these. Cool. There are probably many other options.